Hi, I'm Eric from CanCam CNC Machines, and this is our training video on our C2 ATC machine. For our ATC machines, there's a few common tools that go along with the machine. Some of these are the collet nut, and tool holder. When tool holders are received, the pull stud at the top is often loose, so please make sure it is tight and installed properly. Additionally to that, we have a bracket that you can mount to a wall or fixture to hold your tool holder while you're tightening the tools with the collet wrench. Typical kind of tools with these machines are end mills. This particular one is a compression bit where it has an upcut section at the bottom and a downcut the rest of the way. This helps improve your cut quality on the top and bottom edge of your material. Next is the ball nose end mill. It just has a round shaped tip. The V-bit with common V-bits with different angles. Lastly, this is a surfacing bit. This is mainly used to be planing off spoil boards or your material. When installing your tool into your tool holder, the first thing you have to do is insert your collet into your collet nut. When doing this, we put the end in and press until it clicks. We want to make sure the front surface is flush with the top of the nut. Next, we can install our tool into this collet like so. We want to make sure that it's at least 1.5 times the diameter inserted into your collet. Once that's complete, we're going to thread the tool holder onto the back until snug. From here, we'll install this into our bracket, making sure it seats properly within, and using our collet nut wrench, we will tighten it. Some common terms and phrases used with CNC machines are features like the machine bed, which is referring to the top of the table, our vacuum zones, which are our open ports on the table. There's different sections that go along the table. For the 510 series, we'll have 6 vacuum zones. The first 4 complete a standard 4x8 sheet, and the 5 and 6 zone go along the side and back. Next, we have our axes. The axes are the way the machine moves along and travels for its cuts. We have 3 different axes on these machines. First is our Z axis. It's going to move your spindle, the tool that cuts your material, up and down. Your X axis will move the machine from the left side to the right side, and your Y axis will move from the front to the rear and back. On the auto tool machines, we have tool racks located at the rear of the machine. These are what hold your tool holders and allow the machine to switch tools quickly during programs. The next thing that we're gonna see at the back is our fixed tool calibrator. This is gonna be the device used to calibrate each tool independently so the machine is aware of where the tool lengths are. Last bit is our calibrator probe. This is going to be what tells us where our material or spoil board reference point is on our Z axis. Lastly, we have our control center for our CNC machine. This is the electrical cabinet and controller for the machine and where it gets all the information to perform its functions. The screen up here is our MASSO controller. This is what allows us to control movement on our X, Y, Z axes, as well as run programs and perform cuts. Down here on the cabinet, we have several buttons. This is our main E-stop, and E-stop is used to power off the machine in case of an emergency, followed by our power button, our vacuum pump power, and our locating pins actuation button. Down on the door cabinet here, we have our vacuum zone buttons. Each one of these will open one section of our vacuum zone. This device is called an MPG, standing for Manual Pulse Generator. What its purpose is used for is moving the XYZ axes along very small increments, allowing you to get improved positioning skills when you're setting up your workplace coordinates. Once you have your electrical system hooked up for your machine, it's time to power it on. We want to first make sure your emergency stop is twisted and the green stripe is exposed. From here, we'll press the green power button and boot up the machine. Once the machine is powered on, it's going to ask you to perform 3 tasks. The first is type in a password. From us, that password is always HTG, all in capitals. HTG. You also have the option of changing the password by selecting the Change Password tab here on the screen. You can type your new password in or leave it blank. Next, it's going to ask you to press and release an emergency stop. It's referring to the one on the left hand of your screen or the one located at the top of your MPG. You press it and twist to release. This is just going to make sure that our soft emergency stops are in working order every time you power on the machine. Lastly, we need to home the machine. This is the process in which the machine finds its starting position and allows it to locate all of the tool holders and stroke limitations of the machine. To do this, we're going to double tap the home icon up the top left of your screen. Once the machine is homed, you'll notice that it is in the front left-hand corner. This is commonly known as your machine coordinate home position. And you can see this identified at the right-hand side of your screen where it says machine. The MASSO controller is laid out with several different screens. You can see the screen options located at the very top of your screen. F1 setup page is primarily used for the machine settings and specific locations required for your machine. Typically, you're not going to be going to this page. The next page is your F2 program in MDI. This is the page that you're going to be spending the most time. This is going to be where you're performing your actual machining operations and running your programs. F3 jog is the page that your machine starts on, and it allows you manual control of your machine. F4 tools and offsets is where your tool locations and your workplace coordinates are saved. F5 conversational allows you to make codes directly off the controller. Typically, we don't recommend using this feature as it's much easier and much faster to use your CAM software. F6 load allows you to find and load the programs you wish to cut. When your machine first boots up, it always defaults to your F3 jog page. This is a page that allows you to manually move the machine around with a few different features. Additionally, it defaults you into being in step mode. You can see that indicated by the small green square in the bottom right corner. Below the step mode are 4 additional buttons allowing you to select specific step sizes, also indicated by the little green square in the bottom right-hand corner. To move your machine in step mode, we press our directional keys located at the bottom of your screen. X plus will move the machine to the right, Y plus will move the machine to the rear, Z minus will move the machine down. If you have the rotary attachment for your machine, A plus and A minus will move your rotary. The next control system is continuous mode. Select it and it will begin to flash red. This is typically to warn the user that you're in continuous mode and not in step mode. To use continuous mode, you can press and hold your directional keys and the machine will move continuously until you release the button. You also have control of the speed at which it moves using the feed bar. When moving, the machine will move much faster. The last type of manual control is the MPG. On the left-hand side, there is a black dial that says off XYZ4. This is your axis selection. Turn the dial to the desired axes and you'll be able to control that function. The dial on the right is our step size selection, and it will say ×1, ×10, ×100. Now these are not step values, but if you look at your screen directly above your F3 jogging page, it will say MPG axes, followed by the axes you're controlling, as well as the actual step size you have selected on your MPG. On your MPG, you will notice gradient dials. Each time you move, it will give a solid click to tell you that you have moved the step size you have selected. Additionally, you can continually scroll your dial to move continuously. Next, we'll need to set up our workplace coordinate system. To do this, we need to install a tool in the spindle. The best way to do this with an auto tool change machine is raise your dust boot. To do this, we'll be going to your F2 program MDI page, selecting our MDI mode in the bottom right corner. and pressing the yellow button that says dust hood move down. This will raise your dust boot. To install the tool, we're going to make sure the pull stud is located up. We'll find the hole in the spindle and press the green release button on the side. You will need to hold this button until you have inserted the tool fully, and then release. Once installed, make sure it's fully seated by pulling front to back, left to right, and spinning the tool. From here, we're going to move to our F4 Tools and Offsets page. This is where we will be calibrating each of our tools for our auto tool change machine. Currently, we have tool number 1 in our spindle, so we will double tap our tool 1 selection, followed by pressing our auto tool 0 button. This will automatically locate the fixed tool calibrator at the rear of the machine and move slowly down to touch the tool off accurately. Once this is done, you will press the Save button in the bottom left of your pop-up screen. We will then need to calibrate the rest of our tools to make sure each tool has the correct length in the machine. To do this, we will go back to our F2 Program MDI page. Again, select MDI mode, and we will need to type in a tool change command. Tool change commands typically start with T for tool, followed by the desired number that you wish. In this case, we will do tool 2, followed by M06. This is the command that tells the machine perform a tool change. Once that's been done, we will hit the run key on the MDI screen, and the machine will perform a tool change. Once the tool is changed, you will see the new tool indicated at the top right of your screen. You will then have to calibrate your tool number 2 by double tapping and pressing Auto Tool 0. This process will have to be repeated for each of your tools. Next is going to be setting up our workplace coordinate systems. This is the process in which you tell the machine where the program is going to begin. There's typically 2 ways of doing this. First and most common is using our locating pins to set our corner of the workpiece. This is typically referred to as the bottom left corner. The next process is going to be for irregular shapes such as this one here, and usually we refer to the center of the workpiece for irregular shape. To set our workplace coordinates, we're going to be on our F3 jog page. We're then going to jog our machine roughly to the position we wish to start. Typically, we recommend using a V-bit like the one installed in our spindle. Additionally, we'll want to raise the dust boot so that we can see our workpiece better. Next, we will want to find the very point of our V-bit located over the top left-hand corner. Typically, V-bits are the easiest to find our workplace coordinate systems as they point directly from the center of the spindle. Once close, we can use our MPG to step in closer and get a more refined perspective. Once we are happy with the location of our spindle on our material, we will then set our workplace coordinate system. To do this, we will simply hit the X0 and Y0 buttons at the top left of your screen. You should see the buttons zero out to the right-hand side of it. Additionally, if we look at our machine settings, we will see that our machine settings still have number values there. These numbers will be saved for the reference point of our workplace coordinates on our tools and offsets page. Additionally, we have to calibrate our Z axis. To do this, we will jog the machine up and over top of our material. The next thing we have to do is calibrate our Z axes. To do this, we'll be using the probing screen. To activate the probing screen, we will press the button indicated on the right-hand side of your screen. To activate a probing sequence, we will press the single red dot in the center of your pop-up window. When performing this, if you're using a vacuum system, please make sure your vacuum system is on to get the most accuracy for your machine. Please make sure to set your probe underneath your spindle and on top of your material or machine bed, depending on the reference point you've used for your program. To activate your probing sequence, again, press the single red dot in the center. Your spindle should begin to move slowly down. Make sure your tool calibrator is located properly under your spindle. To confirm all of our workplace coordinates, we're going to go to our F4 Tools and Offsets page and look in the lower section. G54 is the typical workplace coordinate you can use, though you have G55 through G59 to use as well. On the right-hand side of the screen, we will see X, Y, and Z coordinates. The X and Y coordinates should be the exact location where you hit your X0 and Y0 button in the bottom left-hand corner of your program. The Z axis works a little bit differently, as it uses a reference from our Z tool length to say the tool tip on the top of the tool then has to go down an additional negative 0.88 in this instance to reach the top of our particular material. To use the G55 through G59 offsets, we will go back to our F3 jog page, select our probing screen, and we can change between our different offsets by selecting the icon in the top center. Additionally, you can see which offset you're currently working in at the top of your screen, work offset G54. Next, we will need to load a file. To do this, we're going to go to our F6 load page. You will see your files located in the bottom right-hand side of your screen. These are going to be all the files you currently have loaded on your USB. This reads out just like a computer would, and if you have folders to organize your work, you can open and close each of your folders to find the right file. To load the file, we'll select whichever we need to do. In this case, I'll do label cut and hit load. You will then see the file load on the main section of your page. Typically what you see on your page is going to be yellow lines, which are referred to as your cut lines, where it's in your material actually cutting. You'll additionally see white dotted lines. These are known as rapids, where your machine is raised above your material, moving to the next section to cut as fast as it can. Lastly, you will see blue dimension lines along the bottom and left-hand side. These dimension lines are typically referring to the center of your spindle. So please be aware that if you were going to cut out, say, a 5-inch square using a 1/2-inch end mill, your measurements are likely going to read out 5.5 inches to compensate the radius of the tool on each side of the cut. To change a file, you can simply select the desired file, 3D cut, and hit load. For larger files, it takes slightly longer to go, but you will see the cut appear as it would do it on the machine. With detailed 3-dimensional cuts, you can also select a depth map at the top right of the main screen, which will allow you to see how it is 3-dimensionally going to cut. Before we run a cut, we can do what's called a verification process. We use the icon located in the center of our screen right now. This is a digital representation of our spindle in its current location in reference to the job itself. Please note that if your crosshair is not located on the screen or on your workpiece, it is likely because it is out of travel for the particular job you're using, and you will have to move it to the workplace home before you can see a proper verification. To perform a verification, we will go back to our F3 jog page, and we can jog our machine around to find exactly where our cut is going to be. This process is handy to allow us to prevent our metal T-clamps interfering with our cuts, making sure that we want to cut in the right place on our machine bed and perform anything that we don't want to happen ahead of time. We can see that. To verify our Z coordinate is in the position we intend it to be, we can jog our machine down until our Z is almost at 0. We can then confirm that our tool tip is in the correct location. Now you've confirmed that your Z axis is in the correct location. The last thing we'll need to learn is how to set up and run the program. To do this, we're going to run from our F2 Program MDI page. This is typically the page you will be running all of your files from, and we will need to do a few processes before we run to make sure that everything is going to work properly. One of the key features on our running section is our override control. This will allow us to slow down how quickly it's moving across our X, Y, Z axes using our feed control here. This is only going to slow it down to whatever rate you have programmed it to. As an example of this is if you program the machine to run at 100 inches per minute and scroll this down to 50%, your machine will then run at 50 inches per minute. Additionally, you have a spindle override command here, and you will see that you can both increase and decrease the RPM. Typically, the spindle override command is used when your tool bits are getting dull. You can increase the speed of your tool to help that tool last longer. When running a program, we can hit the feed hold button to pause it at any point in time. This is going to stop our XY motion. However, it will not stop our spindle. To stop our spindle, we will need to hit the yellow spindle stop button. When coming back to resume your program, please make sure to hit the spindle CW button followed by your cycle start. It is extremely important to press the spindle CW button to prompt your spindle to turn on before you continue the program. To start your program, you can hit the rewind button once, followed by the green cycle start button. This will allow your program to begin. Alternatively, you can press and hold the green button on your controller to perform cycle start, or the red button to perform feed hold. Lastly, we will go over the jump to line feature. You can activate it by pressing the jump to line button on the right hand side of your screen. You will see a pop-up menu appear with a preloaded line number. This line number is referring to the last line your machine left off on when it powered off or stopped off on your program. This is an extremely useful tool in the case of a power failure in your facility, allowing you to bypass a section of code that you've already performed. Typically, we recommend pulling that back 5 to 10 lines so that your machine runs into the cut. To run your jump to line, you will select a line number you desire. In this case, I'm going to use 457, followed by hitting start from line. This will load up all of our settings for which it was operating at that particular part in your code. You can see this indicated using your X, Y, Z positions, the feed rate at which it was moving, the tool number, as well as the spindle RPM. To run this, we'll just simply hit the run button, followed by pressing the cycle start button. Typically, this is 3 times to allow the machine to line up X, Y, and Z independently to make sure that the alignment is correct. Some common issues when you first receive your machine are your Y-axis gantry being pushed over top of your Y homing sensor upon first power up. This typically will give you a Y-axis alarm shown as such. This is common as the machines are pushed to the front for shipping. And to remedy this, we'll simply need you to power your machine off and manually push your gantry towards the rear 1 to 2 inches. Make sure that you are clear of your Y-axis homing sensor to your Y-axis locating tab. Additionally, it is important to make sure that your compressor is hooked up at the rear of your machine. Otherwise, you will receive a air low alarm. When prompted to press and release your emergency stop upon power up, please make sure you press firmly on the button, making sure it depresses fully, and twist to release. These are some of the common issues that people experience when they first receive their machine. If you have any other thoughts, questions, concerns regarding your machine or operation, please feel free to contact us at support@cancam.ca or using the phone number and asking for our support staff.